Well, howdy there, Internet students. It's Mr. Hermanson again. So today I'm going to take you on a journey to a new way of solving equations. Some of you that are pretty good at solving equations using backtracking will want to be open-minded because this will seem different, but in the end, you'll be able to solve way more difficult equations that you really couldn't solve using any other method. Check out these equations on the bottom of the page. These are all equations that are going to show up in your math and science classes, and you're going to have to be able to solve that. And backtracking will not get the job done. So, so you need to stay open-minded, and a lot of times we're going to be doing equations that are fairly simple that you can see the answer, which is great, but I'm going to just ask that you understand, learn how to understand the process that we're going to do, which is called the balancing method, because you really can't get through any more math at a high school or college level without using this method, at least for solving equations. All right, so to get you introduced to this, we got a little problem here. Um, these two players have the same amount of money, and we want to know how much money is in this treasure chest, knowing that these two players each have the same amount of money. What I'd like you to do is go ahead and figure it out, how much money is in the treasure chest, which I think you can do, and think of a way that you can use equations to get that answer. All right? So I'm going to pause here and let you figure it out, and then when you're done, see if you can write an equation like you did on the last assignment um, to represent this situation. All right, so here's the equation that I think models the situation. Since we know they both have the same amount of money, we can say player 1 is equal to player 2, the amount of money they have. And we can add up player 1, which is 30, and we know that player 2 has a treasure chest full of money plus 11 extra coins, dollars, whatever they are. And so this is the equation we get. Now, last year when you were solving equations, you would just backtrack. You would do 30 minus 11 to get the answer. In the end, when you have a simple equation like this, I'm going to let you do it that way. But I want to demonstrate this idea of this new type of solving equations called the balancing method. And it totally makes sense for this problem. If I were to take away a 5 piece from player 2, I would change the equation, right? But if I also took it away from player 1, it would still represent the same amount of money in the treasure chest, as long as I'm taking away the same amount from both. Actually, I could add the same amount to both too, and it would still be true. Okay, so what I'm thinking, since I want to know what's in this treasure chest all by itself, is I'm going to take away all this, which is 11. And as long as I take away 11 from this side, the equation is still true. I have a new true equation. Now what I just did is I took away 11, and mathematically speaking, we can show that by subtracting 11 from this side. And I also took away 11 from this side. So I end up 30 minus 11 is 19. And on this side, the only thing left is the treasure chest, which I represented with the letter X. And so now I know what is in the treasure chest, what X equals. X equals 19. And I did that by balancing this out. So that's the idea. It's a pretty powerful idea that whatever you do to one side, you do to the other, and you still have a true equation. And the last thing you would always want to do is check your answer, make sure that 30 is equal to 19 plus 11. Make sure you have the right answer, because you might make a mistake along the way. So we can do this with any type of an equation. We can do it with all these equations that you see now, and we just have to know what operation we want to do to get the variable all by itself. And sometimes it takes more than one step. All right, and we're going to use the inverse to get rid of that amount by the variable. All right. So you're going to look at this equation right here, and you're going to say, well, I want to know what x is, so that means I want to get rid of the minus 9. And the way you're going to get rid of the minus 9 is, and so don't even think about the answer at first. But the idea here is that whatever you do to one side, you're going to do to the other. So, so I'm going to draw a line here down the middle, right at the equal sign, and you should do that also. And so whatever you do on one side of the equal sign, you got to do to the other. And as long as you remember that, you'll be fine. Okay? And the thing that I want to do is I want to do the inverse to get rid of this minus 9. If I do minus 9 and then plus 9, essentially that just wipes out that minus 9. It makes it 0. And so the only thing I have left on this side now is the variable x, which is what I want. So I have a new equation that says x equals. Now whatever you do to one side, you have to do to the other. So I have to add 9 over here, and I get 21. And then the last step is just to check your answer. I think there's a spot down here to check it. Yeah, basically you're just going to put 21 where the x is, subtract 9, and make sure it equals 12. Checks out. All right. For multiplication, we're going to do the same thing. We're going to use the inverse operation to undo whatever is by the x, because we don't want that there. So I'm going to put my line where the equal sign is on all of these right now, and you can go ahead and do that. And remember that whatever you do on one side, you do on the other. I don't know if you can tell this, but on this last one right here, that's actually a divide sign. I'm going to rewrite that the way you're going to see your divide signs in algebra. They're always going to look like this. So you might want to rewrite that. All right. Now think about what the inverse operation. This is multiplication. I don't know why they used a dot here either. That's dumb. But so you're going to divide on this one because it's multiplication. You're going to subtract on this one because it's addition. And you're going to multiply on this one because it's division. That x means multiplication, not the variable x. Okay, so to get rid of this 5, if you do 5 times x and then divide that by 5, that will get rid of this 5 because 5 divided by 5 is 1. X, and 1x is just x. But whatever you do to one side, you have to do to the other. So you're going to do 16 divided by 5, which is 12. And then the last step you want to do is just check that by putting 12 where your x is through that multiplication. Make sure it equals 60 like it's supposed to. All right, on this next one, we're going to subtract because we're adding 13. So I'm going to subtract 13 away. That makes that 0, and 0 plus x is just x. So I have a simpler equation, which just tells me what x is equal to. Whatever you do to one side, you do to the other. 62 minus 13 is 49, I believe. And then we're going to check that. We're going to put 49 where the x is. Add this together, make sure it equals 62. Okay, on this last problem, it's divide, so we're going to multiply by 11. Now, right now you're probably saying this is looking a little confusing, but it really isn't. If you take 11 times x and then divide by 11, basically you have 11 divided by 11 right here, which is 1 times x, which is just x. Whatever you do to one side, you do to the other, so we're going to multiply that by 11. And when we do that, we get 1, 4, 5, 2. And then you've got down here, you want to check that 1,452. See if I did my work right. So I'm going to take 1,452 divided by 11 and make sure that equals 132. And so 1452 divided by 11 equals 132. So that's good. Checks. All right, I'm going to put a couple more down here at the bottom, show you a couple more strategies when you're doing this equation stuff. Like what would you do if you had a fraction? Okay, so I'm going to do this, make you an equation here, just write this down. Equals 10. Okay, one strategy, if this number makes a nice decimal, and you can just do 2 divided by 5 to see if it does, then go ahead and change it to a decimal. Well, by nice, I mean it terminates. It's not a repeating decimal. Okay. And then this is multiplication, so you're going to divide both sides by 0.4. When you do a number divided by itself, you get 1x, which is what we want. Sorry, I forgot to put the line down the middle. Okay. And 10 divided by 0.4 is 25. And then you just want to check that by doing 2/5, just in case you did the fraction wrong. Do 2/5 times 25 and make sure that equals 10. So 2 divided by 5 times 25, and it does. Okay, now what if the fraction was like this, 2/3 times x equals, I don't know, so that's not going to be a nice decimal, that's going to be a repeating decimal, maybe it equals 5/9. All right, here's another strategy you can use. Remember that, so we want to divide by 2/3 to solve this, right? Because this is multiplication here. Well, when you're dealing with fractions, the way you divide is you multiply by the reciprocal. I'm sure you remember that from 6th grade math. So what I can do is multiply this 2/3 times 3/2. And remember, whatever you do to one side, you do to the other. And so when you do it on this side, you end up with 3 times 2 on top is 6. 2 times 3 on bottom is 6. 6 divided by 6 is 1x. So we end up with x all by itself, which is what we want. Then on this side, you end up with 15 on top. 5 times 3 is 15. And 9 times 2 is 18 on the bottom. And I would just simplify that. So 3 goes into both of those. So it equals 5/6. All right, so make sure you copy those down. Those strategies will come in handy. One last thing before I let you go here and get you started is when you have negatives, so like let's say I have negative 1.5x equals 10. Okay, now to solve this, I'm going to want to divide by, you guys are thinking 1.5, but you want to divide by negative 1.5 to get rid of that, because you want this to be positive x, not negative x. So if you have a negative coefficient here and you want to divide by a negative. So I'm going to take my 10 and divide it by negative 1.5. And that equals 6.6 repeating. All right. All right, so that should get you started. Make sure you're practicing this. I know that on a lot of these equations, you can just get the answer by looking at the equation. But for a while, practice it. And once you get good at it and we know you can do it, then you can go ahead and take your shortcuts. All right, good luck with that. We'll talk to you soon.